All right, team. No class on Wednesday because of career day, but we got the test on Thursday. So here's some videos to help you out, starting with the do now. I'll explain a few things here and there and also go pretty quickly. So if you need to rewind, feel free to do that. Here we go. Taylor series expansion of e to the x is given above. Great, that's here. Use this to determine the third degree Taylor polynomials for the functions below. So I see I have e to the 3x here. That's helpful. Because this looks just like this, except the x has been replaced with 3x. So everywhere I see an x here, I'm going to replace that with 3x. So here we go. That would be 1 plus 3x plus 3x quantity squared over 2 factorial plus 3x quantity to the third over 3 factorial plus etc., etc., etc. Our general term will be 3x to the n over n factorial. Just be ready for the AP exam and the test on Thursday. Make sure you're able to simplify this. So this would be 1 plus 3x plus 9x squared over 2 factorial plus 27x cubed over 3 factorial plus etc., etc., etc. This would be plus 3 to the n times x to the n over n factorial. That's your answer there. Let's look at the next one. Here I see I have e to the x, which is like what I have at the top here, except I have this extra piece of x here, or extra factor of x here. So if I wanted to get e to the x to look like x times e to the x, I would multiply the left side here by x, and to preserve equality, I would need to multiply each part of the right side here by x as well. So here we go. 1 times x would be x plus x squared plus x to the third over 2 factorial plus x to the 4 over 3 factorial plus etc., etc., etc. Get your general term, x times x to the n over n factorial. And then this term right here could be simplified to be x to the n plus 1 over n factorial. Common base is being multiplied. Hidden exponent here is 1. We can add those common bases. 2 for 2 so far. Let's look at the next one. I see I'm trying to build a Taylor series expansion for e to the x, specifically here for the derivative of e to the x. So I'm going to take the derivative of the left side, that'll give me what I have here, and the derivative of each term on the right, let's see what we get. So derivative of the 1, that will equal 0. Derivative of x is 1. Derivative of x squared, that would be 2x over 2 factorial plus 3x squared over 3 factorial. And then I would keep going, etc., etc., etc. This would become x to the n minus 1 times n over n factorial. Now you're going to notice some things here that'll be important to note. So move the camera a little bit. There we go. If I simplify this term here, this would be n times x to the n minus 1 over n times n minus 1 factorial. So we could write this as x to the n minus 1 over n minus 1 factorial. So that is one general term we could use to produce these terms. Another general term that would also produce these terms would be x to the n over n factorial, which ends up being the same as the general term we had originally. And that makes sense because derivative e to the x is simply e to the x, so they should have the same Taylor polynomial and thus a similar general term. This one would start at n equals 1. Let me try that again. Actually, n equals 0. This one would start at n equals 1 in order to generate those terms. But depending on what n starts at, these will actually be the same. So let's look at the bottom one. Whoops, camera. Bottom one, we're doing the integral of e to the t dt. So we're essentially just going to do the antiderivative. So let me take the antiderivative of each of those terms. So I would get antiderivative 1 would be x, antiderivative of x would be x squared over 2. Antiderivative of x squared would be x cubed over 3 factorial over 3 times 2 factorial plus x to the 4th over 4 times 3 factorial, and then etc., etc., etc. This would become x to the n plus 1 over n plus 1 times n factorial. And we're going to see something also super similar down here. Let me just fix my camera. There we go. X to the n plus 1 over n plus 1. We could rewrite this as x to the n plus 1 over n plus 1 times n factorial. That's like n plus 1 factorial. And notice that this is also similar to that term. This would start at in this case, n equals 0 to get that first term. And then this would start at n equals 0 as well. So this term just doesn't have that 1 there. So there we go. That's the do now. See you in the next video for practice today.